Okay, so what are we doing right now? We are basically discussing the theoretical HR diagram, right? HR diagram. Now I have already talked about this scenario. L, P, we have considered 3 stars. Okay. Using this luminosity relation, we have tried to compare. We have, what did we do? We utilize the fact that they have, these 2 stars have same T, these 2 stars have same L, and then we have found the relationship between the radii of the stars, right? And while doing so, what did we observe? We observe that the radius varies, it doesn't stay constant over the theoretical HR diagram. Fine. So this is our first finding. The second one right now, which you can see on the board, is this. So we have got this relationship, luminosity, intrinsic luminosity of the star, which is the total surface area, R is the radius, of course, and then sigma T to the power 4. Fine. Now I have just written this in a log form, and I am already doing this in a y is equal to mx plus c format. So this is the overall form. And here, this is my C, intercept. Okay, no problem. Fine, no problem. Now, the question is, I am asking you, here, concentrate, I am asking you to draw the same old theoretical HR diagram curves for stars which have the following radii. So, how many classes? 5 classes of stars, right? And I am telling you that this is a very intelligent question, in the sense that you don't have to do anything. What you have to do, remember, observe first. We are physicists, right? So if I ask you to find the temperature of the sun, you don't tell me, sir, give me the thermometer. I will go there, dip the thermometer in the sun, wait for 5 minutes, and then come back. We don't do that, right? We use our black body laws and something else. We use physics laws. Now here also you observe this thing. This is the relationship. So y is equal to mx plus c. Now if this is the curve, what's the slope? The slope is m. Now does m change with r? No. Does m change with t? No. Does it change with l? No, it's fixed. So the first observation is, these curves will remain fixed, the slope will remain fixed even if we change r. So that's the first step. ठीक है sir? No problem. Fine. So what changes? Here r depends, r is only in the intercept. So that's why I have written here that let us calculate the change in intercept for each of the cases. Okay? Fine. So let's talk about the 100 solar radii. What is the value of intercept? This will be fixed. This is constant. So I am not writing it. I am just writing this expression. Okay? So it is twice log. Now when I say this r, I will be doing a sort of comparison. Why? I have drawn this line here, and this is for the case of one stellar radii. Now next time, similarly, log minus log L minus log L solar. So if I do the subtraction, I will just find, I will be finding about the change only, right? So what will be the change? It will be twice log. You see, what's the new r? It's 100 times solar radii. So log 100 base 10, that is 2, right? So it will be 2 into 2 equal to 4. Remember, plus 4. Next, hey, 10. So 2 into again log 10 base 10, that is 1. So it will be plus 2. Next, 1 stellar radii. What? It will be 0. No change. And then you will see the changes are -2 and -4. So this means that what does this mean? This means that if I draw curves like this, then this will be equidistant, plus 2, plus 2, plus 2. Okay, so if this curve corresponds to one stellar radii, then this one will correspond to 0.1. Why? Because the shift is towards negative side, minus 2. Understand? And this one will be 0.01 stellar radii, and this one will be 10 stellar radii, and this one will be 100 stellar radii. Okay? Very basic. Very basic thing. We are just doing this by observing the nature of this relation. Okay. So, constant radii curves on the theoretical HR diagram. Of course, don't forget to write this on the axis.